Okay, good evening, everyone. My name is Peter Abayomi, a research executive in KOMS Software's company. I welcome you to KOMS Software's webinar series on the INSITU GEO software. So I'll be sharing my screen with you so you can follow me as I share my screen. Okay. So the INSITU GEO software by KOMS Softwares was developed. The software was developed by KOMS Softwares, and its first release date was May 2017. The software comes in a combination of 8 test programs in one. It has the cone penetration test, the electrical resistivity test. The software has the flash dialectometer test, pilot test, plate load test, pressuremeter test, standard penetration test, and vein shear test. What the software does is to analyze the test data gotten from the site, and you input your site data into the software, and you get your outputs and even foundation designs. That's for the CPT and for the SPT. You can print your result sheet by pressing Ctrl P, and you can attach it to your SOR report. And the good thing about the software is I don't know of any software that has multiple test programs in one, and you get updates of the INSITU GEO software for free as a licensed user. I don't need to pay for maintenance fee unlike other softwares. It is a one-time buy and it is very affordable. The software is very affordable. So for the sake of today's webinar, we'll be focusing on the CPT, and how to get correlations from the CPT using the INSITU GEO software. The webinar will last for 30 minutes, and there will be time for questions and answer at the end of the presentation. And I also have here with me someone from KOMS Softwares, a technical support in the technical support team. And without wasting much of your time, let us go straight to the presentation. Let us move straight to the presentation. So I'll be sharing my screen with you. Okay. So this cone penetration test, which is the CPT, the CPT involves the use of a 10 centimeter squared or 15 centimeter squared probe, which is pushed into the ground at a rate of 20 millimeter per second. It has a friction sleeve of 15,000 millimeter square surface area and built-in load cells that is used continuously to measure the tip resistance, that is the QC, and the friction resistance, FS. And the friction ratio, which is the ratio of the FS over the QC, that's the friction, the side friction over the cone resistance, is commonly used in the interpretation of results. So here we see the diagram of a cone penetrometer. Yeah, a number of soil parameters and behavioral characteristics of soil can be gotten from the CPT, like the SBT, the IC, which is the material index, the unit weight, effective friction angle, and many other parameters can be gotten from the CPT. And this slide shows the applicability of the parameters derived from the CPT test. Most of the applicability is high, that is high to moderate for soft to organic pit materials. So which means the test is reliable and when you want to get geotechnical parameters, okay? According to Robertson, 2010, when it is not feasible to obtain undisturbed samples of soil, the total unit weight can be estimated from using the relationship below. And also, Main 2014, he suggested the relationship for unit weight, this relationship for unit weight. And also in 2016, he also suggested this relationship. He suggested this relationship for unit weights for soft to firm clay, where MQ, where the value of MQ is the ratio of the resistance to depth. And to capture variations in the unit weight estimates, Main and Pochin in the year 2012, they gave this expression for the unit weight in a dimensionless form. Also, researchers like Robertson and Campanella, 1983, Collaway and Main, 1990, they gave correlations for the estimation of peak friction angle of sand for the CPT. So Robertson and Campanella 1983 gave this suggestion for the peak friction angle. Collaway and May in 1990, they gave this relationship for peak friction angle. And several estimations and correlation of geotechnical parameters by researchers are obtainable using the CPT in the INSITU GEO software. These are some parameters and the researchers use for analysis in the software. Like you have your SPT N60, that's correction for field procedure, SPT N160, correction for field procedure, and also overboarding pressure. So let us quickly move on to how to analyze the CPT using the INSITU GEO software. Let me move to the software. So I'll be sharing the screen that shows the software, the INSITU GEO software. Okay. So this is the interface of the INSITU GEO software. This is the introductory page of the software. The software has the CPT, the electrical resistivity tests, DMT, that's flight electrometer test, pilot test, plate load test, the pressuremeter test, the SPT, the vane shear test. And you can see these are the notes on the software, so you can read the notes on the software for the various test programs. And here is the CPT. Then the CPT comes with an assisted mode. This is the electrical resistivity test, the flat dialectometer test, the pilot test, the plate load test. We have the pressuremeter test, standard penetration test. The standard penetration test also comes with an assisted mode. So this is the assisted mode. But for the sake of today's webinar, we'll be focusing on the CPT, analyzing your field data, the data you get from the field with the INSITU GEO software. So here already, because of the time, I have values or data imputed already. So here is the input general. This input general here is where you input general details of your tests and the equipment used during the test. The project, you have the project name, the test location, the type of method, you have the test number, the reference, the weather, the date of the test, and for the ground level, a value must be imputed. You have the ground level ordnance datum, the name of organization which made the test, the details, the test operator, test checked by, approved by, and here you input the type of machine used to carry out the test, if it's a mantle or a friction cone. You have the details of the cone number, the sleeve number, the piezo cone number, and its capacity. For this test, I used a 10-ton capacity for cone, sleeve, and piezo cone. And here I input the value for the area of cone base. I select either 1000 or 1500 millimeters squared, the calibration reference, for the cone, for the sleeve, and for the piezo cone. And if it was backfilled, the backfill method type, and the sleeve external surface area, which is mostly 15,000 millimeters squared, the net area ratio of cone, which is 0.7 to 0.8, depending on your machine calibration. And moving on to general details, we have the QC and the FC. If it measures in megapascal, click yes or no. Then, does your machine measure in kilogram per centimeter squared? If it's not in megapascal, yes. So you can click yes or no. If it doesn't measure in kilogram per centimeter squared, then to measure in kilonewton. And here you input how your machine takes measurements, either in QC and QS or QC and QC. Okay, so moving on to the input table. Here are just the general details. Then moving on to the input table. Here, in the input table, you manually input the depth and the corresponding QC and QS value, or QS and QT value, depending on how your machine takes measurements, which you will have imputed or specified in the input general. So if your machine measures pore water pressure, that's if it has a piezometric sensor, you can input the values of the pore water pressure at the various depths. So I manually input the depths, the QC, and the QS. So for this test, the depth, the maximum test depth was 14 meters. 14 meters. So I have my QC and QS for the 14 meters test depth. So moving on to the output table. So you can click to move to output table. The output table gives the geotechnical correlations at the various test depths. That's from 0 meter depth to the 14 meter depth according to my data. So you can get your friction ratio, that's the RF, the friction ratio. You also get the soil type. You get the soil profile at each depth. You get the soil profile at each depth. There are a few software out there that relates CPT with soil profile. And the INSITU GEO software does that with a measure of relative density. The soil profile is determined with a measure of the relative density. So you get the soil profile at each depth. So you can have an idea of what kind of soil it is at varying depth. So that is the soil profile based on SBT. And you also get the estimated unit weight, the estimated SPT N60 value, estimated N160 value. You get the estimated peak friction angle, the estimated peak on drain shear strength. You get the relative density, estimated relative density. You get the estimated over-consolidation ratio. You get the estimated shear wave velocity, estimated small strain shear velocity. You get the estimated Young modulus. You get the estimated permeability at various depths, at the test depth. That's from 0 meter to 14 meter according to my test data I input. So let's click on to move to output graphs. You get necessary graphical representation from your tests, like the QC, the current resistance versus the depth. You get your friction ratio versus depth. You get the pore water pressure versus depth. You get several other graphical representations based on your inputs. You get your SBTN versus the depth that shows the soil profile. You get the corrected cone resistance versus the depth. So the INSITU GEO software gives you necessary graphical representations of your data you input into the software. Then quickly, let us move to the foundation design. The foundation design. So you move up and click on Input Foundations. Input Foundation. So this section is for shallow foundation. This is for shallow foundation, and this section is for deep foundation. So you input your foundation details for both shallow and deep foundation, depending on what you want to design for. So here you input the footing depth. My footing depth is 1 meter. Input the footing width, the footing length, the footing section type. If it's a square, rectangular, or circular footing section, then I input my load on footing for the shallow foundation. So let me click on the output foundation to get my foundation designs. Okay, here I get the ultimate bearing capacity, and I also get the net allowable bearing capacity of 500 kilonewton per meter square, and a total settlement of 90.81 millimeters for my footing section. So that being said, let's move on to back to the input foundation and for the deep foundation design. Okay, for the deep foundation design, I input the pile depth. I want my pile to terminate at 10 meters, and I select the pile section type, if it's a square or circular footing. Then I want a pile diameter of 450 millimeter. Then the pile group section width, I input the pile group section length, and the load on pile group, I want a 2000 kilonewton load on the pile group. So moving on to the output foundation. So this section is for the deep foundation. This section is for the output of foundation for the deep foundation. So I get the ultimate load of a single pile, that's this value in kilonewton, and the safe load for a single pile after dividing the ultimate load by a factor of safety. And I also get an elastic settlement of pile group for this for this load. And also, the CPT comes with an assisted mode for easier foundation designs. It comes with an assisted mode. Most engineers use this in practice. You do not need to input your data again from the CPT primary. And let's move on to the assisted mode. So from input general, click to switch to assisted mode. So you have all your data inputted already. This assisted mode is just to assist engineers or geologists on foundation designs using the CPT. So for the assisted mode, let's click to move to foundations. Sorry, input foundation. So the same thing, I have designed for the shallow foundation and for the deep foundation. So for the shallow foundations, the load on footing is automatically calculated. That is it uses the bearing capacity at the footing depth, that's at 1 meter, for the footing length and width is used to determine the load on the footing. And that is the bearing capacity, which was, when we click to move to the output, we see the bearing capacity. So for a bearing capacity of 500 kilonewton multiplied by the footing area, which is the length times the width of the footing, to give you the maximum load the soil can carry in kilonewton. That is the bearing capacity multiplied by the footing area will give you the footing. We give it the footing length, the footing load. So click to move to input foundation. So that's why we have 750 here. Okay. Then you select the tolerable settlements. You select a tolerable settlement. So you have for pad foundation, you have 25 millimeter, you have 50 millimeter, 40 millimeter in clay for pad foundation, and for raft foundation, you have 75 millimeter in clay. And you can also manually impute the tolerable settlement. Perhaps you want a value different from this, you can just manually impute it. Say you want a settlement of 30 millimeter, you get an error and a message pop up that please impute the tolerable settlement in millimeter. Okay, click OK. Then here, let's check out the output. Here you get your settlements. This settlement was the initial settlement for a bearing capacity of 500 kilonewton per meter squared. But since you want the tolerable settlement to be 30 millimeter, it gives you the recommended bearing capacity for this settlement. So I want my tolerable settlement to be 25 millimeter. That is for pad foundations. Okay. So you see, for 25 millimeter settlement, I get a bearing capacity of 367.06. So the initial bearing capacity of 500 kilonewton per meter square for a load of 750 kilonewton will give a settlement of 34.1. But since the tolerable settlement was set to 25 millimeter, a linear relationship is assumed between bearing capacity and settlement, which will make the bearing capacity to become this value for a settlement of 25 millimeter, meaning a load of this 367.06 times the footing area, that's the bearing pressure times the area, will give 550.59. That is the load that the soil can carry for this settlement and at this bearing capacity. So moving on to the deep foundation design. So also I want it to terminate at 10 meters, sorry, and I select the pile installation type. I want a CFA board pile, estimated CFA board pile value, or for a driven pile. So I want a CFA board pile estimation. And also I can impute the pile diameter. Notice for this pile diameter, say if I have a pile diameter of 450 millimeter, I get a message here that reduce load. So when you get a message like this, it means that your design will not work for this configuration. So it's either I reduce the load on the pile group, or I increase the diameter of the pile, say 600 millimeter. So this would work. And also I select the pile spacing, and the the load on Power Group is just assumed for a single, for a floor, a maximum column load of 500 kilonewton is assumed per floor, sorry. So for 4 floors, we have that's 4 times 500, which will give me 2000 kilonewton. You can also alter this. Probably you want a 250 kilonewton, so you just input 0.5 here to get a 250 kilonewton load on Power Group. So you get the Power Group section width automatically and the Power Group section length automatically. And let's click to see the output foundation. Okay. So here we get the elastic settlement of Power Group, and we get the ultimate load of a single pile and the safe load of a single pile for an estimated CFA board pile. And you get the number of piles in Power Group. The INSITU GEO software has a result sheet. So click to move to result sheet. The result sheet is also present in the CPT primary and the assisted mode, depending on which you want to use in your soil report. So here you have all your general details in a presentable form. You have your graphical representations. You have all the graphical representations. You have the outputs. You have all the outputs and also foundation designs. You also get your foundation design. These are the outputs. So you have everything in a presentable form or in a presentable manner. And by pressing, okay, here's your foundation and details. So by pressing Ctrl P on your system, you can print the result sheet. You can easily print the result sheet. So here you select the number of pages you want to print. Say this is page 1, page 2, 3. So here you input the number of pages, say from page 1 to whatever page you want to print. And also you can save your work as a PDF file. You can save it as a PDF file by clicking on Microsoft Print to PDF. Okay, then moving back. So this is the assisted mode. You also get to print your result sheet from the primary version. So let me click to Impute General, then click to move to primary version. So here you can also print by pressing Ctrl P, you can also print your results sheet from, you can also print your result sheet the same way for the assisted mode CPT. Okay. So that brings us to the end of the training on using the INSITU GEO software